everyone. Ooh, let me erase it. Wow, today is Friday, December 2nd. And well, we only have 1 week of classes left, right? And so today we will finish 7.5 and maybe start a little bit of 8.1. And then over the weekend, you can work on the homework from 7.1 to 7.5. And then we have a quiz. This is the last quiz, okay? Quiz 8 on Monday. So it covers sessions 7.1 to 7.5. All right. Do you receive my email about video session? It's on next Wednesday from 8 to 10 p.m. virtual. And there is also a study session on Tuesday in the science conference room in Andover Common, and from 6:30 to 9 p.m. So that one is an in-person study session. So feel free to go there and work on your stuff and ask me questions. And besides that, let me pull out our course. Yeah, so quizzes on Monday. It covers 7.1 to 7.5. Review session on Wednesday. I will also make the recording. We will go over our practice final exam. And our final exam is on Wednesday, December 14th from 1 to 3 p.m. in this classroom. So this is the practice final exam. It's due on the final exam date, but everything else, you must submit those by next Friday, December 9th. Okay, and next week, if you want to show me your notes, you can also come to my office hours or email me to make schedule a time. It just takes me 5 minutes to just go through your notes. Okay, so make sure you don't miss any example, because if you miss one example, you lose 0.1. So that means if you miss 10 examples, then you don't get any notes bonus. Okay, so all the notes are posted on the website. If you miss some class, you can do in the notes. Okay, and then yeah, study sessions. So the study session is organized by the Office of Diversity and Inclusion. So I will have with the Tuesday. So next Tuesday from 6:30 to 9 p.m. We will be in the science conference room, and there will be snacks and music. So Donna Boys will be there. I'll be there. Really good. So Donna Boys is psychology professor. Donna Boy biology professor. Donna Brownie English professor will be there. So you can go there and study. Okay, but the style is like you ask me a question and then we go over the questions. Okay, because it's open to all Indiana Tech students. Unlike our review session, it's me going over the practice exam, so this is open to all. And we also have a Sunday, December 11th from 4 p.m. to 7 p.m. But I won't be there. But Dr. Udita Kanagamala will be there. So Dr. Kanagamala is another Precalculus professor. Okay, so yeah, I take up this session and you take up that sessions. Okay. All right. So today, let's look at session 7.5, solving trigonometric equations. So when we talk about 7.1 to 7.4, we did some examples about trig equations, right? So today we focus mainly on that. So to solve a trig equation, first, if possible, graph the equation first so that you can see what kind of answer to expect. What does that mean? Well, if you have a simple equation such as like sine x equals root 3 over 2, well then what do? You graph the sine, right? You graph the sine and you think about, okay, root 3 over 2 is, oops, okay, so this is pi over 2, and pi over 2 is 1, and then root 3 over 2 is kind of like here. So that's why we know, oh, it must be pi over 3 or 2 pi over 3. Okay, so if you have like equation only involve a trig function, function, you isolate the trig function, you look at the graph of it to figure out what's the angle. Okay? And then use identities so that the only one of the trig functions occurs the equations, and every occurrence of that trig function has the same argument. So argument is the same as the angles. So if you have like cosine 2x and cosine x, then you want to use the double angle formula to change the cosine 2x in terms of cosine x. So you make the angle to be the same. Okay, everybody? Sometimes factoring first can lead to minimal equations, each of which has only one trig function. This means you don't need to use the trig identities. So if you're able to factor them, so you have a product of two factors equal to 0. Then you set this factor equal to 0 or this factor equal to 0. Therefore, you don't have to make sure those angles are the same. Okay, then you can solve them independently. Right. Use algebra to isolate the trig function. Okay. Use inverse trig functions and the unit circle to find the angle or angles that solve the equation. So it's really up to you. You can use the unit circle. Me, I like to look at the graph because the graph tell me like all the quadrants. So it's your habits. If you like to use unit circle, use unit circle. If you like the graph, you use the graph. Okay, everybody? And check your answers. Sometimes an dictionary solution is introduced when you square both sides of the equation. Right. So check your answer and see if that makes sense. Okay. Let's look at the following. The first one. Solve 3 tangent theta minus square root of 3 equals to 0. Okay? Do you see we only have one trig function is involved? But in this case, we isolate the trig function. Isolate means you want to have the trig functions by itself on one side, and all the other stuff on the other side. Right, everybody? Okay, so what do we do? So isolate the trig function. Bless you. So we add square root of 3 on both sides, right? Then we have 3 tangent theta equals square root of 3. By the way, because you only have one angle, it's okay that you don't write the parentheses. Yeah, you can write the parentheses or you don't have to write the parentheses. They mean the same thing. Okay. And then continue. What do we do? Divided by 3. So we divide it by 3, we get square root of 3 over 3. Yes, everybody? So, what's next? Well, it's good to draw the tangent. Well, the graph of tangent looks like this. Yeah, everybody? This is minus pi over 2, and that is pi over 2, right? And root 3 over 3. So what's that? Okay. And here, let me pull out that formula. Okay. That's why you're going to be familiar with the table, the common angle values. Okay. Root 3 over 3 is the same as 1 over root 3. Is everybody okay with that? And tangent, see, pi over 6. Yes, everybody? So pi over 6. So pi over 6, right here, pi over 6. So theta equals pi over 6. But if our angle is between minus pi over 2 to pi over 2, then we are at the pi over 6. But you can have infinitely many copies of that because this is a pi periodic function. The period is pi. Therefore, you put pi over 6 plus k pi. Okay, because you have more of them. Okay, you have more of them. So what's the k times the period? The period is pi. So far, so good, everybody? K is an integer. So you can say K is an integer, or you just say K it belongs to the set of integers. So usually I write this because it's easier to write that. You okay with this notation? This is belongs to symbol. And this is like the C, and then you put the little line symbol in the middle. K belongs to Z. Z is the set of integers. You know, real numbers is R, rational numbers is Q, complex number is C. Right, everybody? Mm-hmm. Okay, so this is problem 1. Okay, when we only have one trig function, well then you just use algebra to solve that trig function isolates, and then you can draw the graph and use our common values, okay, this table to figure out the angle. And if your angle is not restricted in a range, then please plus k pi if the period is pi, or plus 2k pi if the period is 2 pi. Like sine, cosine, secant, cosecant, the periods are 2 pi. Tangent is cotangent, the periods are pi. Yeah, everybody? Okay, number 2. All right. Number 2, if you're able to factor it. Factor it. Okay, so what do we do here? I see the common factor cosine theta. Please don't divide cosine theta. Okay? Never divide a variable. So if you have 2 on the left and 2 on the right, you can both have divided by 2 because 2 is a number. But if you see cosine theta as a common factor, don't divide cosine theta. Okay? So be careful. Don't divide expressions involving a variable because that will lose. So this will lose some solution. So never divide expression involving a variable. So what we should do is move all terms to the left-hand side and factor. Okay, so move all terms to the left-hand side. So we add cosine theta, we add cosine theta. Therefore, we get cosine theta cotangent theta plus cosine theta equals 0. Thank you. Right, everybody? By the way, I say don't divide, but you can add or subtract any expressions. Yeah, just don't divide. Okay. Ooh, do you see the common factor is cosine theta? Yes? So factor out cosine theta. Oops. So after we factor that out, what's left? Cotangent theta plus 1 is 0. Right, everybody? Oh, how nice. So after you factor it, then you set each factor equal to 0, and you put OR to connect them. So you have cosine theta is 0, or cotangent theta plus 1 is 0. Okay, cosine is 0. So after you get to only one trig function and you already isolated, then you can draw the graph. What's the graph of cosine? It's wave. It starts with 1. Exactly. So it starts with 1, like that. Okay. And oh, do you see? This is pi over 2. This is 3 pi over 2. When do we get cosine theta is 0? Well, that's when theta is pi over 2 or theta is 3 pi over 2. And the cosine is 2 pi periodic. Okay? So to describe all these solutions, you can say theta is pi over 2 plus k pi. Okay? So, yeah, because you want to include both of them, and then so you put k pi there. It actually includes pi over 2 plus 2k pi and the 3 pi over 2 plus the 2k pi. You combine them to get this. Is that okay, everybody? Mm-hmm. All right. How about the other one? So cotangent theta, we subtract 1 on both sides. Yes, everybody? Cotangent. What's the graph of cotangent? Is let's review. Not here. Okay. Cotangent. See? Cotangent is a decreasing function and from 0 to pi. Right, everybody? Mm-hmm. That's why you gotta be familiar with the trig graphs. Okay, so from 0 to pi. Minus 1. Oh, you see? Minus 1, this is pi over 2. So minus 1 corresponds to what? 3 pi over 4. You see? Pi over 2 is 0. Then you can imagine 1. 1 is pi over 4. So negative 1 corresponds to 3 pi over 4. So theta is 3 pi over 4 plus, what's the period for cotangent? Pi. Therefore, you can put k pi. So k is an integer. Hi. So this is problem 2. Don't forget to watch the recordings to catch up. So any questions? If you are able to factor it, then you move all the terms to the left side and factor it. Set each factor equal to 2. And then you can draw the trig function to figure out the inverse. Okay. Problem 3. Okay. Problem 3. Do you see? We only involve the sine x, but we have sine square and sine x. Right, everybody? So this type is like, we call it is a quadratic type. Okay, so this is a quadratic type. Okay, where you have sine x, and you also have sine x squared. Is a quadratic type. So what you do is do a u substitution. So let u be sine x. Well, then you have 2. See? Why did 4 just pop there? You see? Interesting. Okay, why there is a 4 there? Weird. Okay. Okay, so I don't know what happened. So, okay, 2u squared minus u minus 1 equals 0. See? If you use the trig function and the square of that trig function, this is a quadratic type. Then you can let u be the sine x, and this is 2u squared minus u minus 1. See? The quadratic equation. How do you solve quadratic equation? Either factor x or quadratic formula. Yeah, everybody? So if you're not familiar with the factoring, you can do quadratic formula. What's quadratic formula? Negative p plus or minus square root of p squared minus c over 2a. Yes. Okay. Here, can we factor them? What's the factor of 2u squared 2u and u, right? So, and then factors of -1 is 1 and -1. Where do I put the 1? Where do I put the -1? Here we want to put 1. And then here we put the -1. So this will give us, yeah, 2u times -1 is -2u. U times 1 is u. When we add them up, we get -u. That's the middle term. That's the third example in section 7.5. Okay, so this is how we factor it. And now we set each factor equal to 0. So 2u plus 1 is 0. Or u minus 1 is 0. Solve for u. What's u? We move the 1 to the other side and divide it by 2. Yes, everybody? Or u equals 1, right? Now pack it back. What's u? U is sine x. We're not done, okay? So we have sine x is -1/2, or sine x equals to 1. By the way, your sine and cosine, let me use this color. So your sine and cosine is always bounded between 1 and -1. So if you get this number is like 3, then you know, no solution. Don't need to solve for that. Is that okay, everybody? Sine, cosine must be between -1 and 1. So -1/2, that's possible. 1, that's possible. 5, not possible. 10, no. Right. Yes. Okay, good. So yeah, we continue. Here, sine. You know, sine looks like that. Okay, this is pi. -1/2. Well, -1/2 is like here. Yeah, this is -1. -1/2 is half of that. Do you see we have these two angles? And which angle? Oh, not here. Sine 1/2 pi over 6. Yes, everybody. The reference angle is pi over 6. Therefore, this angle is pi plus pi over 6. Do you see that, everybody? Maybe let me make it smaller. Okay, -1/2. Okay, so we know 1/2. The reference angle is pi over 6. Therefore, this one is pi plus pi over 6, which is 7 pi over 6. Yes? And how about this one? This is like 2 pi minus pi over 6. Yeah, everybody? So 2 pi is like 12 pi over 6. And minus pi. So that is 11 pi over 6. Is that okay, everybody? Therefore, x is 7 pi over 6 plus 2k pi, because it's 2 pi periodic. Or it could be 11 pi over 6 plus 2k pi. Because we have two angles. Those two angles give us sine x is -1/2. Is that clear, everybody? Yes. Right? All right. And so this is the sine. 1. Where is 1? Oh, right here. Do you see what is that angle? It's quite slow here. So let me get freezing. Oh, I got frozen. So let's see. Oh, okay. Yeah. So this is what? Yeah, how about you? So x equals pi over 2 plus the period, 2k pi. So these are the solutions. And we know k is integer. So far, so good, everybody? So this is a problem 3. Okay. So it's a quadratic type. We do a substitution first, and we solve the u. Make sure the number is in the range minus 1 to 1, and now we can get here. Look at the graph of sine and figure out the angle. Okay. All right. So let's keep going. Okay. Solve this. Okay. This square, kind of quadratic type. But do you see this is a sine, this is a cosine? Yeah, everybody? This is sine and cosine, and we cannot factor it, right? It's a sum, it's not a product. So in this case, you want to change the trig functions so that you only have one type of functions. And you know sine and cosine, they are related by trig identities. Which one? Sine square plus cosine square equals 1. Right, everybody? So use that trig identities. Yes, everybody? Okay. Sine square plus cosine square equals to 1. See? Then we can express the sine square in terms of the cosine square. Right, everybody? By the way, can I change this cosine to sine? The answer is you don't want to do that. Because, okay, why? You know, sine square plus cosine square equals 1. So when you want to express the sine square in terms of cosine square, then your sine square is just 1 minus cosine square. Yeah, everybody? That's easy. So change the sine to cosine is easy. But if you want to change the cosine to sine, ooh, that's hard. Because, you got to do cosine square first. That's 1 minus sine square. And then, the cosine x. When you take square root, it's plus or minus 1 plus sine square. Oh my goodness. Do you want to replace the cosine with this plus or minus square roots? No. That's why in this case, change your sine square in terms of cosine. Don't change the cosine in terms of sine. Okay, everybody? Okay, so change the sine square in terms of cosine. So 2 times sine square is 1 minus cosine square. Don't forget the parentheses. That's the common mistake. Plus 3 cosine x minus 3 is... Okay, now we distribute. So 2 times 1 is 2 minus 2 cosine square plus 3 cosine x minus 3 equals 0. All right. Can we combine the like terms? You see, 2 minus 3 is what? 2 minus 3 is negative 1. Right, everybody? By the way, I don't like my leading coefficient to be negative. Do you like that? No, right? So we both sides multiply by minus 1.
We get 2 cosine squared minus 3 cosine x plus 1 is 0. Right, everybody? Ooh, this is a quadratic type. What do you let u to be? Cosine x. Yes. So we let u be cosine x. Then what do we get? So 2u squared minus 3u plus 1 is 0. Aha! You can see? We got, is it minus 1 and minus 1? Will give us negative 3u, right? So 2u minus 1 is 0. What's u? What's u? 1/2. Or u is 1. Ooh. Both of them are good. Right, everybody? Both of them are good. Because both of them is between minus 1 and 1. So that's possible. Okay, let's see. So cosine x is 1/2. Or cosine x is 1. Cosine x. What's cosine x look like? Let me put here. Right? This is 2 pi. This is pi. This is pi over 2. 1/2. 1/2. So this is 1. 1/2 is right here. So this angle. Yes, everybody? Right? And okay. 1/2. 1/2 is what? Was cosine. 1/2. You see? Pi over 3. Yes, everybody? So that angle is pi over 3. So this is pi over 3. Oh, not only that, but also that. Okay. Yeah, not only this angle, but also this angle. You know the reference angle is pi over 3, but then this is what? This is then 2 pi minus pi over 3. Do you agree? Yes, everybody. So this is 2 pi minus pi over 3, which is, 2 pi is 6 pi over 3. So 6 minus 1 is 5 pi over 3. Therefore, x is pi over 3 plus 2k pi, or x is 5 pi over 3 plus 2k pi. Yeah? How about cosine x is 1? Or cosine x is 1, that is what? X is the 0 or the 2 pi. And you can express as 2k pi, exactly. So these are the solution. K is any integer. So far, so good. Everybody? All right. Keep going. Okay. Yeah, so this example is harder because you have different trig functions. Then you need to use the trig identities to express so that you only have one trig functions, and then you can solve it. Okay, problem 5. Problem 5, we only have one trig function. Yes, everybody? But the angle is not x. It's okay. Let's isolate the trig function. So we add root 2 on both sides. 2 cosine x over 2 is root 2. Yeah, isolate it. So divided by 2. We get root 2 over 2. right? Okay. So we already isolate the trig function. Then what do we do? Draw the cosine. Okay. So if your angle is not exactly x, in this case is x over 2, you can think of this as like theta. Okay? Then this is the cosine theta. And then you think about, oh, cosine theta is root 2 over 2. Okay? So root 2 over 2, which is kind of like here, right? Root 2 over 2. What's that angle? Root 2 over 2. And that's pi over 4. Do we have root 2 over 2 or root 2 over 2? Yeah, root 2 over 2. So you see, that's pi over 4. So this is pi over 4. And how about here? This will be 2 pi minus pi over 4. Do you agree, everybody? So this pi over 4, and my graph is not so good. So this should be also pi over 4. The reference angle is pi over 4. So that's why this angle is 2 pi minus pi over 4, which is, so 2 pi is 8 pi over 4. 8 pi minus pi is 7 pi over 4. Therefore, our theta, okay, so theta is pi over 4 plus 2k pi, because cosine has period 2 pi. Or theta is 7 pi over 4 plus 2k pi. Okay? Not done yet, because our theta is x over 2. Theta is the argument, is the angle. But we are looking for x. Okay? So theta is x over 2. Then what is x? 2 times theta. Yes, everybody? Is that okay, everybody? So if the angle is not exactly x, then you call it theta. Then you look at the graph of cosine theta and figure out those angles. Okay? This is theta. You want to find the x. Theta is x over 2. What's x? Both sides multiplied by 2. See, your x is 2 times theta. So 2 times pi over 4 give you pi over 2. 2 times 2, that gives you 4k pi. Yes. And then, or x is, see, this times 2 give you 7 pi over 2, right? Yes, everybody? 7 pi over 2 plus 2 times 2 is 4k pi, where k is an integer. Okay, so we summarize. If the angle is not exactly x, okay, let the angle be theta. Then draw the trig graph. Figure out the theta values. Then solve for x. Is that clear, everybody? So there's a process. If your angle is not exactly x, okay, then you let it be theta. It's like, do you remember we grabbed the trig function? You have 4 columns. You have theta and sine theta, and then you figure your x, and then you figure your y, and then you look at your x and y to draw the what the point of this. Here's the thing, right? You call the angle be theta, okay? And then you look at the graph to figure out the theta values. And then you solve for x, figure out the x values. Okay, everybody? All right. Keep going. Okay, here. We have sine squared and cosine squared. So this problem, two ways to solve it. One way, you can change the cosine squared to sine squared. Then you get an equation involving sine squared. Second way, you can change the sine squared to cosine squared. And then you get equation involving cosine squared. Which way do you prefer? Change the sine squared to cosine or change the cosine? Doesn't matter. Sine to cosine, okay. So we are also using the trig identity, sine squared plus, here we use the angle theta. By the way, the angle, you can call it anything, right? Call it x, call it theta, call it ut, anything. Okay, so change the sine square to cosine square. Then sine square is 1 minus cosine square. Right, everybody? Okay, plug in. So 2 cosine square minus 2 times sine square. Sine square is 1 minus cosine square plus 1 equals 0. Right, everybody? Okay. Here. So 2 cosine square minus distribute. 2 times 2 is 1. Negative, negative become positive. 2 cosine square plus 1 equals 0. Yes, everybody? Okay, here we have, let's see, combine the like terms. This is plus, right? Combine the like terms. Then we have 4 copy of cosine square. What's the constant term? -1. Oh, you see? We can solve for cosine theta. We add 1 on both sides. We get 4 cosine square equals 1, right? What's next? Divided by 4. So if cosine square equals 1 over 4. What's next? Take the square root. Remember, when you take the square root, you actually get plus or minus. Yes, everybody? When you take square root, you get plus or minus. What's square root of 4? Yeah. Therefore, we actually get 1/2 or -1/2, right? Okay, let's draw a picture. Cosine, like that. 1/2. 1/2 is what? Cosine, what angle is 1/2? Yeah, pi over 3. Right, everybody? So, pi over 3. Okay, how about there? Do you see this is pi over 3? And then here is what? 2 pi minus pi over 3. Yes? Right? 2 pi minus pi over 3, what's that? What? 5 pi over 3, right? Yes, so theta is pi over 3 plus 2k pi, or theta is 5 pi over 3 plus 2k pi, or when do you have negative 1/2? See, this is negative 1/2 right here. Okay? Do you see here that the reference angle is pi over 3, but then here, yes, yeah, reference angle is pi over 3, but then this is pi minus pi over 3. Do you see that, everybody? This is pi minus pi over 3. So pi minus pi over 3, which is 2 pi over 3, right? How about that? See, this is pi. Your reference angle is pi over 3, so then this is pi plus pi over 3. Yes, everybody? Yeah, so be familiar with the reference angle. So this is 4 pi over 3. So you get theta is 2 pi over 3 plus 2k pi, or theta is 4 pi over 3 plus 2k pi. Yes, everybody? So you can leave your answer like that, or you can combine them, okay? Or you can combine them. So this angle and this angle, okay? So let me see. This one and this one, you can combine them. You get theta is pi over 3 plus k pi. See, it was 2k pi, but when you combine them, you see, pi over 3 plus pi is 3 pi over 3, 4 pi over 3. Therefore, you combine them, you get pi over 3 plus k pi. You see that, everybody? And these two, you can combine them. You get, so these two, you combine them, you get theta is 2 pi over 3, 2 pi over 3 plus k pi. Okay, so instead of these 4 expressions, you can use the 2 expressions. But you know the difference? It was 2k pi, but then here is k pi. Okay, we learned a lot today. Yeah, and k is any integer, right? So this is problem 6. Okay. Okay. Any questions so far? No? Okay. So keep going. All right. This trig equations involve sine and cosine. Right, everybody? Well, if you want to change the sign in terms of cosine, you have like this plus or minus square root. Right, everybody? Or if you change the cosine to sine, you have plus or minus square roots. So what do we do better is we want to, do you see the right hand side is only sine x? Yeah? If we square both sides, we get the sine square. So that helps us to get rid of the square root. Because you don't want to use the actually plus or minus square root to plug in it, right? What do I mean? Yes. You don't want to use the plus or minus square root to plug in it. This is so ugly. Yeah? So that's why here, what we do is square both sides to create the sine square on the right hand side. Okay, then you might ask, oh, this is only for this problem we can do that. By the way, in general, if your problem like that, then you want to move this to the left, so then you only have the sine x by itself on one side. Then when you square it, then you get the sine square. Okay, if you have the sine minus 5, then you square it, No, that's also good because not only you have sine square, you also get minus 10 sine x plus 25. This one you get stuck. So you want to make sure you only have the sine or cosine on one side, and then you square. Okay, so this method squaring both sides is only for this type of problems. Okay, everybody? All right, so then we have cosine x plus 1 square equals sine x squared. What's sine squared again? Trig identity. Sine squared plus cosine squared is 1. So sine squared is 1 minus cosine squared. So I hope you're very familiar with the trig identities. So sine squared is 1 minus cosine squared. See? This is how we get rid of the sine. Okay, expand that. Cosine squared, cosine plus 1 square is, what's that? Cosine square plus, what's complete square? What's complete square? What's complete square? Yeah, a squared plus 2ab plus b squared. Therefore, you have cosine squared plus 2 cosine x and plus 1. This is on the left-hand side. Right, everybody? Don't be a fool. Yeah, make sure you understand it. Okay. In this case, what do? Move all the terms to the left-hand side. Right, everybody? It's a quadratic equation. So move all the terms. Just move to the left. You have add cosine squared. So we have 2 copy of cosine squared. And do you see this one cancel? Yeah, when we subtract 1 on both sides, the 1 cancel. Oh, do you see the common factor? Yeah, what's that? Yes. Oh, great. If we have a product of 2 factor equals 0, and we set each factor equal to 0. So cosine x is 0 or cosine x plus 1 is 0. Cosine x is 0. What's the angle? Pi over 2. Or what? 3 pi over 2. Yes? So that is pi over 2 plus k pi. Yeah, you can combine them. Pi over 2 plus k pi. Right, everybody? And how about here? Cosine x equals minus 1. Minus 1. When do you have minus 1? Pi. See? Pi plus 2k pi. So this is the answer. So far, so good, everybody? All right. Here, we need to check our work. Okay, so this problem need to check our work. Why? Because when you square both sides, we will get some extra solution. Okay, those solution might not be the solution because okay, you have 1 equals 1, but minus 1 is not equal to 1. But when you square both sides, they're equal. Okay, so this is what I mean when you square both sides, you will create some solution. Those extra solution might not be the solution. That's why here you need to check. All those previous examples, you don't need to check because the process you're doing, you won't introduce more solution. Okay? But here when you square both sides, you may introduce some extra solution, which is not the solution. That's why here we need to check. Okay, let's check. So for pi over 2 plus k pi, you can think of pi over 2. Okay, so actually, if you look at this picture, okay, what are the three solutions? They are the pi over 2, they are the pi, and the 3 pi over 2. And then when you add a multiple of 2 pi, it's the same, right? So it's enough to just check these three. Okay, let's check this one. Pi over, so x equals pi over 2, okay, which is right here. Our left-hand side. What's cosine pi over 2? 0. Yeah. So left-hand side is 0 plus 1 equals, what's sine pi over 2? 1. See, sine pi over 2 is 1. So good. This is the solution. How about when x is pi? Cosine pi is -1. Sine pi. Yeah. Ooh. So it's -1 plus 1 equals 0? Yes. X equals to 3 pi over 2. What's 3 pi over 2? What's cosine 3 pi over 2? 0. Yes? Right, everybody? 0. But what is sine 3 pi over 2? What's that? -1. Is 1 equal to -1? No. Oh, no. So 3 pi over 2 is not a solution. See, this is not a solution. So therefore, the solution are x equals pi over 2 plus k pi, 2k pi. We cannot put k pi. Okay, pi over 2 is not the solution. Or pi plus 2k pi. These are the solution. Okay, so this is wrong. This is not a solution. Okay, everybody? Yes. Okay, good. Let's keep going. Yes. Because we talk about a lot of different type of examples, so like here we're just lecturing. But I hope when you get home, do your homework, do more practice. You learn math by doing a lot of exercise, right? Our course is just because we don't have enough class time. We cannot do more like group work in the class. But I hope you can do it after class. So solve for the trig function, right? We subtract 3 on both sides, and then we divide by 3. So we get tangent of x over 2 equals -1. Do you see the angle is not exactly x? Yes? So you do what? Tangent theta. What's the graph for tangent? Like the cube function. So 0 pi over 2 minus pi over 2. -1. When do you have -1? That angle is what angle gives you -1? Okay, what angle gives you 1? Pi over 4. If this is pi over 4, what's this? Exactly, -pi over 4 plus k pi, because the period is pi. That is theta. So theta is x over 2. What is x? what is x? Solve for x. 2 theta. Right, everybody? So you get, oh, okay. Multiply the theta by 2. Then you have, what's 2 times that? Negative 2 plus 2 times that, 2k pi. K is any integer. So far, so good, everybody? So this process works for all the examples. For example, I want to make the problem harder. If you have like tangent, a 6x minus pi, our 6x minus pi by 2 equals to minus 1. Well, then this is your theta. So you have theta equals 6x minus pi by 2. And then when you solve for x, you have what? Theta plus pi by 2 is 6x. And then x is theta plus pi by 2 over 6. So your angle could be more complicated. And then you just solve for x. Yeah, everybody? So in this case, when you plug in x, what happens? See? When you plug in x, you get x is theta. Theta is negative pi over 4 plus k pi. You want to add pi over 2 to it, and then you want to divide it by 6. Right, everybody? Therefore, you know pi over 2 minus pi over 4 is pi over 4. Yes? So pi over 2 minus pi over 4 is pi over 4. So you get that. And pi over 4 over 6 is the same as pi over 4 divided by 6 plus k pi over 6. Therefore, you get pi over 24 plus k pi over 6. So this is how you solve it if your angle is more complicated. Okay, everybody? Yeah, I did the same thing. Okay, last example. Your turn. What's the trig identity involves secant and tangent? What's the trig identity involves secant and tangent? Yeah, secant squared is tangent squared plus 1. Secant squared by tangent squared plus 1. And then solve for tangent. Get a quadratic tag and then draw the graph of tangent. Yes, do it, do it. Do it, do it, do it, do it. Do it, do it. Everything on the left. Then you can do it. Secant squared, the trig identity. Secant squared is 1 plus tangent squared. Secant squared is 1 plus tangent squared. Secant squared is 1 plus tangent squared. Yeah. Here. See? See? Tangent squared plus 1 is secant squared. Yes. So be familiar with the trait identity. Oh.
Okay, the solution of this problem is posted on the website. The notes with answers. So once you finish, check your answer at home. Don't forget to do your quiz on Monday. Bye. Have a nice weekend. Thank you. Yeah, don't forget to watch the recording.
Yes.
I just want to let you know, I'm gonna do the exam.
Okay.
Not it, but thank you.